Okay, guys, this is a review for Chapter 8, Lessons 1 through 4. And the 4 lessons are, in order, I think: fractions as division, greatest common factor, simplify fractions, and word problems, strategies for solving them. Okay, this is Lesson 1. John has 5 pizzas to serve 8 friends. How much pizza will each friend get? Okay, 5 pizzas. What the heck? Let's draw a little picture here real fast. So we got pizza number 1, pizza number 2, pizza number 3, 4, and 5. Now, how much is he going to give to his friends? Well, he can't give every friend a whole pizza because I don't have 3 friends who don't have food. So here's a tip for you. We're trying to take 5 pizzas and we're trying to divide them up so that 8 friends get an equal amount. All right, if you think about this, it doesn't make sense. After all, you have 8 friends. Well, these are the friends, and let's say you gave each friend a pizza. We got a little problem here, don't we? Well, don't you have more friends? That's 5. Here's 6. Here's 7. Here's 8. Now think about this. If you can't give every friend a whole pizza, I'll bet you can give every friend part of a pizza. Now, that's what we simply have to find. How much pizza, or what part of a pizza will each friend get so they get the same amount? This could not be easier. Do not complicate this. What are we doing? What are we splitting up? Are we splitting up the people, John's friends? Well, I certainly hope not. Or are we splitting up the pizzas? Well, yes, we're going to cut up the pizzas, not the friends. So listen to what I just said. I said splitting up. We're splitting up the 5 pizzas, okay? So whatever's getting split up into parts, you put up on top of the line for a fraction. Whatever's getting split up goes up. So 5 is being broken into 8 parts for 8 friends. So guess what? You have just finished the problem. Each friend is going to get 5/8 of one pizza. That's it. It couldn't be easier. Let's just change the problem a little bit here. Change the numbers. All right, John has 6 pizzas to serve his 11 friends. How much pizza will each person get? So you don't even need to draw the picture. What is going to get split up? Think about it. You have 6 pizzas. 1, 2, 3, 4, 5, 6. And you can't give each friend an entire pizza. So each friend is going to have part of a pizza, correct? It should make sense too. Okay, so here we go. What's being split up goes up. Are you splitting up the pizza or the friends? Again, let's not cut up people. So I'm going to put the 6 up here. Get ready. And 11 down here. And you found your answer. Each friend will get 6/11ths of a pizza. Let's try one more. I'm just going to erase it this time. I'll put this. We'll go like this. We'll say 8 pizzas. And now we'll say, oh boy, 7 friends. Okay. 8 pizzas and 7 friends. All right. So what do we got to do? If we have 7 friends, 1, 2, 3, 4, 6, 7, and 8 pizzas, okay, each of them are going to get a pizza, right? 4, 5, 6, 7. How many pizzas do we have? Oh, we have an extra pizza, correct? Because there's 8. Well, shouldn't every friend get a little bit of this pizza? A part of it, a fraction of it? So we got to split that pizza up into a certain number of parts so they all get part of it. So they're all going to get one whole pizza and a little bit more. But how much? First question, what's being split up? The pizzas are being split up. There you go, 8. Now, how many friends? 7. Now, check this out. The answer is 8/7, but there's something wrong here. Have you ever seen a fraction that has the top number larger than the bottom number? Well, we don't use that usually. So we call them improper, like the British. They would say that's an improper fraction. You can't try that. But wait a minute. Didn't we learn that fractions are just division problems? And we always divide up even when it looks weird. Well, this one doesn't look so weird because 7 will divide into 8. And watch what happens. Again, this is because we have an improper fraction. We have to simplify it, make it easier to understand, because that's weird. 8/7. So divide the 7 into 8, multiply, put your answer down, subtract, put your answer down, and you're done. But you're thinking, what? How am I done? Well, here's your answer. All division problems, the answer starts at the top here in the quotient. That's 1 whole. I'll put that here. And 1/7. So what did I just find? I found out that each person here, each person's going to get 1 whole pizza and 1/7 of another pizza. Every one of them. Now, if you're still having a hard time with this, check this one out. Let's say we have 2 pizzas. 2 pizzas, and you have 3 friends. They're going to come over and eat your 2 pizzas. 2 pizzas, 3 friends. Whoops. I'm writing yeah, that's right, 3 friends. So how much pizza will each friend get? Now let's use a little common sense first. Draw a picture if you have to. You got 2 pizzas, and you got 3 hungry faces down here. Well, that guy could eat a whole one, that guy could eat a whole one, but there's nothing left for this guy. Bummer. So each person's going to have to get part of one of the pizzas, a part of them. Okay, don't complicate this. What's being split up? The pizzas, right? What's being split up goes up 2, and we're splitting it up amongst 3 friends like this. Each friend, now there's your answer, is going to get 2/3 of 1 pizza. Now watch what happens. This will really help you to understand it. Okay, I'm going to make my big Y. This is a great way to divide a pizza into 3 parts. You kind of think of a big fat Y, like that. So the parts are pretty similar. Okay, how many we have? We have 3 friends. Oops, sorry. Okay, and each friend's going to get 2/3, right? Here we go. Okay, friend number 1 will be in, let's see, green. Okay, friend number 1, we'll put 1. He gets 2 out of 3 parts. That's 2/3. Friend number 2 will be in pink. Okay, here's friend number 2. Wait a minute. Where's the other third going to come from? Oh, we can jump over to this pizza. So this guy, Mr. Pink, he's going to be able to get 1/3 of right here of the pizza, and he'll have to come over here and get his other third. Now, we have 1 more friend left, and let's see here. I have blue. Here's friend number 3. 1/3 and 1/3. Isn't that so cool how that works? So each friend's going to get 2/3 of a pizza. Okay, let's do one final one. I'm going to increase the size of the numbers, but that won't hurt anything. So let's say we have 27. We're having a big picnic. 27 pizzas. Now, this could be anything. It could be 27 brownies, pizzas. And you're going to have like a big reunion, family reunion, and you're going to have 63 people have to eat 27 pizzas. So in a perfect world, each person would get a whole pizza, right? I can't believe I wrote pizzas. 63 people. Family members. There we go. Sorry about that. Perfect world, each person would get a whole pizza, but there's only 27 to go around. So that means no one's going to get a whole pizza. All right. Ask yourself, what's being split up? The pizzas. So whatever's being split up goes up. Like this. Being split up by the people, 63 people. It's like a division problem. Now, let's think about this. 27 over 63. That's a pretty complicated number to really understand. Let's stupefy it, or simplify it, because you have to simplify all fractions. So this kind of goes to the next lesson. And remember that little song I taught you? Simplify a fraction by dividing both numbers by, and I told you to do it this way. Put your division symbol there and another fraction. So simplify a fraction by dividing both numbers by the 27 and the 63. The largest factor both numbers have in common. The largest factor that both numbers have in common. We also call it the greatest common factor. Let's see. Well, how do we figure out what the factors are for 27 and 63? Always start with 1. Go like this. This is just a methodical way. In other words, very systematic. Get used to doing it one way, and you'll master it. Okay, 1 times 27 are factors. Oh, but you're like, well, it's a factor again. I forgot. Remember that On Top of Old Smoky song? On Top of Old Smoky. Remember that? I can't sing. You know that. It goes, what is it? The product is the answer when you multiply numbers called factors, like 7 and 5 is 35. Okay, so factors 27. 1 times 27, now go to 2. Can 2 work? 2 times anything? No, because 27 is odd. How about 3? Well, think of your math facts, multiplication facts. Sure, 3 times 9. What about 4? Thinking of any math facts or multiplication facts that were 4 times something equals 27? No. What about 5? No, we know that numbers that end in 5 or 0 can be divisible by 5, so that's not going to work. What about 6? 6 times anything equals 27? What about 7? No. 8? 8 times 3? It's 24. 9? Guess what? You're done. You found them all. Did you hear what I just said? I said 9. Okay, but I already used the 9. So once you have a duplicate, you can stop there. Okay, now let's do 63 here. All right, so what do? We start with 1 times 63. Those are 2 factors. And we go to 2 next. Well, 2 only can divide into even numbers, so 2 times nothing will equal 63. What about 3? Well, I'll tell you a little trick here, and it was this. To find out if 3 can go into a number, well, let's say 63, for example, add the digits together. Okay, what do you get? 9, right? Well, does 3 go into 9? Sure does. So that means 3 goes into 63. Isn't that cool? So I wonder how many times. Well, think about it. 3 times 20, 3 times 21. I'll save you the time there. 3 times 21 is 63. Next one, 4. Will 4 go into 63? Think of your multiplication facts. No. What about 5? Well, 5 only goes into numbers that end in 5 or zeros. That won't work. What about 6? Well, I taught you a little trick with this one, too. 6 will go into a number. Let's see if it goes into 63. And you don't have to divide it. Just try it first. If both 2 goes into that number and 3 goes in, well, 3 will go in. We just did that one, right? But 2 won't go in because 2 only goes into numbers that are even. So 6 doesn't work. What about 7? Oh, think of your math facts. 7 times 9 is 63. What about 8? 8 times anything? How about 9? Oh, you used 9 already. See, we used it already, so we're done. As soon as you find a duplicate, you're done. Now the next step is super duper easy. All we have to do is follow our song. Simplify a fraction by dividing both numbers by, what was it? The largest factor both numbers have in common. The largest factor. Okay, let's circle all the factors they have in common. Don't just, trust me, do it this way. You'll make fewer mistakes. Okay, so they have 1 in common. Let's go to 27 now. Do they have a 27 in common? Nope, you can cross it out if you want. What about a 3? Yep, they got a 3 in common. There we go. And last one is a 9 up here. Do they have a 9 in common? They do. And it's so easy to see now that we have 9 as our largest factor that goes into both of them. So here we go. Top divided by top, 9 into 27 is 3. And 63 divided by 9 is 7, right? So 3/7 of a pizza is the amount of pizza that each person in this reunion is going to get. 3/7. You have 63 people. So you take a pizza, you split it into 7 parts, 7 slices, 4, 5, 7. Well, that's pretty good, actually. That's not too bad. 7 equal-sized parts. And let's see. Each person is going to get 3 of them. 1, 2, 3. Then another person comes along. Hey, how much pizza can I have? You can have 3 slices. 3 out of the 7, okay? All right, next person comes along. Hey, I want some pizza. Well, you get 3/7. Okay, here you go. There's 1. Hey, I need more pizza. That's only 1/7. Oh, yeah, that's right. We have more pizzas, dude. Calm down. Okay, so let me slice this sucker into 7 parts. 3, 4, 5, 6, 7. And now we're going to get your pizza, my friend. That's right, don't be shortchanging me. So what is he going to get? He is yellow, so he only has 1 over here, right? 1/7, so he's going to get 1 from over here and over here. And that's just going to continue on and on and on until all 63 people have 3 slices of pizza or 3/7. So when you do these problems, make sure you simplify. Simplify. Make sure you follow those songs too. All right, this is our final example. 4 friends and 10 pizzas. Wow, that's a lot of pizza. Okay, so each friend is clearly going to get a pizza and some more, correct? Okay, so what's being split up? The friends? We're going to cut the friends up today? No. Let's split up those pizzas. 10 pizzas. Now, we want to split that by 10 friends. 10/4, right? No, that's not proper. The English say you can't do that. So how do you simplify this guy, though? Remember, this is an improper fraction. We're not going to use our simplify a fraction song. We're going to divide up because that smaller number could go into that larger number, can't it? So make sure you know how to simplify these improper fractions versus regular fractions. Okay, so 4 into 10 goes 2. That's 8. Then we subtract, we get 2. Now, this presents a little problem here. You're probably thinking, oh, yeah, I know what this is. And I'm sure you're right. 2 and 2/4, right? Now, let's use a little common sense. 2/4 is not in simplest form. And you can't put that down as your answer because from here on out, for the rest of your natural life, all fractions need to be simplified. So 2/4, I mean, what's a better way to say it? What's an easier way? Let's stupefy it or simplify it. Isn't it just 2.5? I mean, we really shouldn't even have to, do that problem. Write all the factors out for 2 and 4. Simplify a fraction by 2/4, right? Dividing both numbers by the largest factor that goes into both numbers. I shouldn't have to go like this. Okay, let's see. What are the factors of 2? 1 times 2, that's it. Okay, what about 4? 1 times 4 and 2 times 2. Then you got to circle the common factors, right? Well, they both have 1s. They both have 2s. And that's it. So 2 is the biggest one. Simplify a fraction by dividing both numbers by the largest factor that goes into both numbers. Now, 2 divided by 2 is 1, and 4 divided by 2 is 2. And isn't that what we just found? So we shouldn't have to do all that garbage, just a little common sense. So each person is going to get 2.5 pizzas. Holy smokes. 4 friends, 2.5 pizzas. Wow, a lot of food. Now, we go on to simplify fractions and greatest common factor, and guess what? We basically did that with the last lesson. We combined them. So let's do this. Here we go. If I give you 3 numbers and I ask you to find the greatest common factor, that sounds really intimidating and crazy sounding, isn't it? Okay, well, let's see. Greatest means largest, and let me put 3 numbers down. Why don't we put down 14, 18, and 24. Now, if I ask you to find the greatest common factor, that means the largest factor they have in common. Okay, so let's see. Oh, I remember how we do this. Just list them like this. 14, 18, 24, just as if we were doing one like this, a fraction. Just list them like this. Now let's list our factors for them. Okay, 14, what are the factors? Well, we got 1 times 14, and we have 2 times 7. Anything else? No. What about 18? You know your math facts. 1 times 18. Go to 2 now. 2 times 9. Go to 3. Will that work? Sure. 3 times 6. And are we done? 4, 5, 6, 7. Yep, we're done. Okay, and then 1 times 24. Then try 2. Will 2 work? Sure. 2 times 12. What about 3? Does that go into 24? Sure. 3 times 8. What about 4? 4 times 6. What about 5? No. What about 6? Oh, we already used 6. So if someone asks you to find the greatest common factor for 3 numbers, that means they just want the largest factor they have in common. Just list the factors. This couldn't be easier. All right, let's find the largest factor. Well, they all have 1s. Don't skip this step. Do what? Now, come up to here, 14. 14, Any 14s in the other ones? No. Okay, so bye-bye. What about 2s? Are there any 2s down there? And all 3 of them? You have to have one in all 3. Yep, I see a 3. I see 3 of them. I meant. I see 3 2s, okay? Now we have a 7 left. Is there a 7 in all 3 of them? Nope. So our greatest common factor is 2. That's the largest number that'll go into all 3 of those numbers. Nothing else. That's the largest. All right, example number 2 for greatest common factor. If I had these 3 numbers, if I have 72 and I have 28, I used that again, didn't I? And 36. All right, let's see here. I want you to find the largest factor they have in common. So list their factors, find the biggest one. Okay, so let's see here. What I'll do is I'll write them down like this so I can make a list. 28, 36, and 72. All right, here we go. 1 times 28, right? What's next? 2 times 14. Hope that's what you were thinking. Does 3 work? No. 4. 4 times 7 works, right? What about 5? No. 6? No. 7? Oh, we already did 7. We're done. All right, 36. 1 times 36. Then, does 2 work? 2 times... Yes, because it's an even number. 36 and 2 get along. 2 times what? Well, let's pretend you don't know. Just come off to the side and divide it, and you're going to get 18. So 2 times 18. What about 3? Well, remember, if you add the digits, will 3 go into 36? Well, look at 36. Add the digits. 3 plus 6 is 9. Will 3 go into 9? Yep, it will. Then that means 3 goes into 36. And then if you don't know that, you'd have to divide it, but it's 3 times 12. Now what about 4 into 36? Think of your multiplication fact. Sure, 4 times 9. What about 5? Well, 5 doesn't work because it only goes to numbers that end in 5 or 0. What about 6? Multiplication facts again. There we go. Woo! This is really going on. Oh, we have duplicates, so we're done, right? That's right, we're done. Now let's go to 72. 1 times 72. 2. Well, it's an even number, so 2 works. So if you don't know what it is, just come by here and divide it, and you're going to find out that it is 2 times 36. 3. Will 3 go in? Now, this is where I always say to you, don't judge a book by its cover. Don't judge a number by the way it looks. You're thinking, oh, 3's not going to go into 72. No, always check. Well, what is our rule for 3? If 3 goes into a number, what's that rule? Well, if once we add the digits of the number 72, that's 7 plus 2 equals 9. If 3 can go into that number, then 3 can go into that number. So now you get to come off to the side here and say, oh, okay, I wonder what it is. And you do this, and you're going to get 24, by the way. So that's 3 times 24. Now what about 4? Don't worry about 4, the divisibility rule. All right, so does 4 go into 72? No, don't ever do that. Check it. Don't judge the number by the way it looks. 72. Well, just see how many 4s are in that thing. And you got 1. That's 4. That's 3. That's 32. It's 18. So 4 times 18. Never assume a number can't be divided by another number. Check it. Okay, what about 5? Well, 5 doesn't work because it doesn't end in 0 or 5. What about 6? Well, let's see. Oh, remember this rule? 6 goes into numbers only if 3 goes into the number and 2 goes into the number. If 2 works and 3 goes in also, guess what? 6 will work. Does 2 go into 72? Sure does, because it's even, right? Does 3 go into 72? Yeah, we already did that one, so it's 3 times 24. So now, 6 into 72. We can come off to the side here and say, well, how many times? That's 1, 6, that's 12. It's 12 times, by the way. I don't feel like wasting your time here. 6 times 12. All right, we've gone, let's see, 1, 2, 3. We've gone 4. We skipped 5. We're up to 6. Does 7 go into 72? Well, of course not. 7 times 10 is 70. Sometimes 11 is 77. What about 8? Oh, math fact. Ding, ding, ding. 8 times 9, 72. Okay, what about 9? Oh, we already did 9, so we're done. Now, we listed all those factors. Ready? We just got to find the biggest one to find our greatest common factor, or the largest factor they have in common. Well, they have 1s in common. There we go. I'll pick a new color for each one. How's that sound? We'll make this fun. Okay, do they have any 28s there? Let's see, 28s, 28s. It has to be 28 in all 3 of them. Nope, so that's gone. Are there any 2s in all 3? Yep. 1, 2, 3. Okay, next color. And we'll go with, well, come on, colors, yellow. All right, let's go to the next number, 14. Are there 14s in all three lists? Nope, it's got to be in all three, by the way. What about a 4? Do you see a 4 in all of them? Yes, I see a 4. There's a 4. 4 and 4. 4! I'm thinking of golf. Sorry about that. Okay, 7, 7, 7. Are there 7s in all three of them? Nope, there isn't. Hey, by the way, notice something here. If you put them in order from least to greatest like this, all you have to do is look at this list of numbers. You don't have to keep going and looking at these and all these too. Just do it like that. Anyway, 4 is the largest number they have in common, or the largest factor. And what does that mean? 4 is the largest number that goes into 72, that goes into 28, and that goes into 36. Okay, try one more. If I ask you to find me the greatest common factor, G, C, F of, let's see. Well, we'll go with 2 numbers. Get ready. This is going to be really, really hard. No, it's not. 124, 84, and 87. Oh, there we go. Okay, greatest, that means largest. Common means the same factor. So we got to find the factors. Then we got to find the ones they have in common. Then we got to find the largest ones in common. So this is funny. It's backwards, isn't it? You find the factors, and then you find the common factors, then you find the biggest ones. You're kind of working backwards here. I never noticed that till now. Well, okay, so list your numbers, and I suggest putting them in order from least to greatest like this. Just makes it a little easier. And now it's time to start listing factors. Okay, factors of 84. Well, we know 1 times 84, and I'll go boogieing along here. 2 works because it's an even number, so 2 times what, 42? Does 3 work? You're not sure, are you? So come off to the side, 3. Oh, there's a trick, isn't there? 84, what do? You add the digits, 8 plus 4, and that's 12. Does 3 go into 12? Then 3 goes into 84, so now I get to go find out how many. 3 into 84, that's 2, that's 6, that's 24. Sorry, I'm going fast here. It's 28. So 3 times 28, who knew? Well, I'm glad we checked. What about 4? Does that go into 84? Well, I'm pretty sure it does, so I'm just going to check. 4, 2, 8, 0, 4, 1. Yes, 4 times 21. Look at that. Okay. Now, what about 5? No, because it doesn't end in 5 or 0. What about 6? Well, if 2 goes into the number, remember that? If 2 can go into 84, and if 3 can go into 84, then 6 goes into 84. Well, does 2 go in? Sure, we already did that one, right? Does 3 go in? Yes! So now we can come over here and see how many times 6 does go into 84. And I happen to know that. 6 times... Anyone know? 6 times what? 10 would be 60. 12 would be 72. 13 times 6. No. What about 14? What's this? Times 6. 24, 84. 14. Now, oh my goodness. What about 7? Does 7 times anything equal 84? Probably not, but let's just check it. Oh my gosh, it's true. It works. Look at this. 14, that's 2. It's 12. Wow. 7 times 12 is 84. Now what about 8? 8 into 84. Well, 8 times 10 is 80. Yeah, that's not going to work. What about 9? Know any math facts? 9 times 9 is 81. That won't work. What about 10? 10 to no. What about 11? Well, 8 times 11 is 88. No. What about 12? Oh, we already did 12, so we're done. Phew. This is a long one. All right, let's go. 87. Oh, gosh. They can't have other factors other than that. That's a weird-looking number, isn't it? Well, never judge a number by its cover. Okay, 87, the Sidney Crosby number. Will 2 go into 87? Can I use 2? Nope, because it's not an even number, is it? What about 3? Well, let's see, 87. Oh, if we add the digits, we get 15. Now, will 3 go into 15? Yep, that means 3 goes into 87. So we come off to the side, we divide it, 3 into 87. We get 2, we get 6, we get 2, we get 27. And that's not, oh my gosh, 3 times 29. And that, my friends, is those are the only other factors there are for 87. We could continue on and check more and more and more, but no sense in doing that right now because we don't want to waste too much of your time here. And I think you're getting the gist of it based on what I've seen in class at least. So let's finish this up here. I got quite a mess, don't I? A little house cleaning here. Dun, dun, dun. Okay, pick a new number, new color. What are we going to pick? We'll pick green. I like that green. Okay, 124. Well, 1 times 124, right? What's our next factors? 2. 2 will work because that is an even number. 124. Just give it some thought here. 2 times 60 is 120. I'll bet you knew it's 2 times 62. What about 3? Well, let's add up the digits. 1 plus 2 plus 4. That's 4, 5, 6, 7. Now, does 3 go into 7? No, so 3 is not going to go into 124. What about 4? Well, here is the rule for 4. I'm only going to tell you this to you once, but when you get into the bigger numbers that have 3 digits and 4 and 5 and 6 digits, now you can use the rule for 4. If 4 goes into the last 2 digits, then 4 goes into the entire number. So if you have something like this, too, 736, if 4 goes into the last 2 digits, and it does, 4 times 9, right? Then 4 goes into the whole thing. One more, what if you have 328? Now, does 4 go into the last 2 digits? Sure. That's 7 times, so it must also go into 328. So 4 times what is 124? I'll just come down here and divide it. 4 to 12 is 3, 12, 0, 4, 1, 31. Who knew? Now, 5. Well, 5 won't work, no, because it doesn't end in 0 or 5. What about 6? Well, what's the rule for 6? If 2 goes in, yep. Hey, there's 2. And 3 goes in. 3 didn't work, so 6 isn't going to go in. All right, what about 7? Well, we learned that rule in class. Not really. That's a crazy rule. All right, I don't know. So let's just come off to the side here. 7 into 124. I doubt it because it looks funny. No, we don't want to say that. Oh my gosh. It actually worked. So hopefully you now know never to trust what your eyes are telling you. Oh yeah, 7 can't go into 124. No way. It looks weird. Nope, it worked. I'm like, cool, always check. 7 times 18. Now, we go to the next number, 8. 8 into 124. Let's see. I don't know. And I don't know the rule for 8. I can't remember what it is. So that's 1, that's 8, that's 4, 4. 8 into 44 doesn't work, so 8 doesn't work. Wow. What about 9? Well, are we going to check it? Sure. But we learned a rule about 3. Do you remember the rule about 3? It also works for 9. You just add the digits up. 1 plus 2 plus 4. That equals 7, right? Well, does 9 go into 7? So 9 does not go into 124. Okay, now let's go to 10. Well, 10 times 12 is 120. No, that's not going to work. 11? Well, I don't know. 11 into 124. And we didn't really learn any divisibility rules for that, did we? 111, that's 14. No, it doesn't work. What about 12 into 124? Well, let's see. 12, 124. Well, I know 12 times 10 is 120, right? No, it's not going to work. What about 13? What about 14? Well, we don't know about 13, do we? So let's just check it. 13 into 124. So it's an odd number into an even number. 13 into 124. Well, let's use some common sense here. 13 times 10 would be 130. That's not going to work, is it? No. What about 14? 14. Well, if you're not sure, check it, right? Well, I'm here to tell you something, kids. 14 not going to work. 15. It doesn't 124 doesn't end up in a 5 or 0, so that's not going to work. What about 16? 16. We never want to assume, right? Well, let's see. 16 times what into 124? Well, I know that 16 times 10 is 160, so I got to back off a lot. I don't know. What do you think? 16 times 7, maybe? Let's see. Oops, that's what is that? 16. There we go. 7 times 6 is 42. 7, 8, 9, 10, 11. That's 112. We're close. Why don't we try 8? I wonder if it's going to work. That's 128. It missed, so that doesn't work. What are we up to now? We just tried 16. 17. Well, I'm just here to tell you right now for time's sake because I'm looking at the clock. 7 doesn't work. Oh, but guess what? We already tried 7. That's a duplicate, so we're done. Now, let's just have some fun and circle our common denominators. Well, this one's got a 1, this one's got a 1, that's got a 1. What about an 84? Do they all have 84s? No. What about 2s? No. What about 42s? Nope, they don't. What about 3s? Oh, here's a 3. There's not a 3 on the other one, though, so get rid of that. What about 28? Nope. What about 4s? Nope. Just one of them has a 4, so it doesn't count. About 21s? Nope. Wait, what about 6s? Nope. Wow, this is a bummer. 14s? Nope. What about 7s? Nope. And what about 12s? Nope. Guess what our greatest common factor is? Get ready. Brace yourself. You're going to hate me. It's 1. The largest number that goes into all 3 of them is 1. That's it. Isn't that crazy? Anyway, sorry to take you through that, but there were a lot of good learning moments in here, and I had to do that to you. Okay, there's the letter U. I don't know why I did that. Okay, and finally, lesson 4 was all about word problems, right? Now listen, step number 1 with all word problems, read slow. Read the whole thing first. Read from beginning to end. And then read it slow and write down what you know. Whatever comes to mind in any way you want. Draw a picture, make a table, whatever you want. Make an equation, an expression. Write it down. Read it slow. Write down what you know. Okay, that could be anything. Now, 3. My favorite and probably the best tool you'll ever use with word problems is called the T-chart or table. Tables work great. Another one you can look for, will patterns help you to solve your problem? What else could we use? Well, sometimes we have to like 6 times some number equals 42. And you're like, oh, I don't know how to find that number. Sure you do. Well, multiplication goes this way and division goes this way, right? So 42 divided by 6 is going to give us our mystery number. So use opposite operations. Next one, if you find yourself able to solve a problem by repeatedly subtracting the same number, like if you have 12, when you take away 2, now you're down to 10, okay? And then you take away another 2, then you're down to 8. Take away another 2. If you find yourself doing that, don't do that. Use division instead, because repeated subtraction is really time-consuming. Instead, we can use division. The same is true for repeated addition. So if you can answer the problem using repeated addition, stop, say, whoa, 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 whoa. There's an easier way, and it's called multiplication. So I don't know how to really write that down here for 6 and 7. So I'll put a plus and a minus sign. Number 8, can you think of any other strategies? Well, when you get to your practice test today, at the very beginning under the instructions, I list a whole ton of strategies. Well, not a ton, but I list quite a few. Think about those. Don't give up. Pretend like you have to get it. You can't quit. Oh, there's the songs, aren't there? And sometimes I gave you tricks like the big G. You can use that as a strategy. And we learned about PBMDAS. Those are called mnemonic devices. PBMDAS. Parentheses, brackets, braces, exponents, multiplication, or division, whichever comes first from left to right. And then addition and subtraction. And let's see, is there anything else we've learned that we can help? Well, we have, but I'm not going to tell you the other ones. Okay, I hope this really helped. And your next job is to go to class marker, and it is this lesson, math, chapter 08, I think I put it as, lessons 01 through 04, and I think it says practice test, like that. Now, lastly, show your work on scratch paper. Show work on scratch paper. Okay, that is what you need to turn in. Show work on scratch paper and turn in, turn in, turn in, turn in. All right, signing out. See you guys.